Hello, calculus type people. Hope everyone's day is going absolutely amazingly. Tried to fix a few of the bugs with the videos. I hope this gets better. I really do. Uh, I've switched to pencil. I'm not doing notes in my fancy erasable pens anymore. We have switched to pencil, and it shall stay a pencil for the remainder of forever. Okay, so last time we talked about limits and what a limit is. We know a limit is what it's approaching, right? What a function is approaching as c goes to a certain value. So as limits as x goes to c. And we read this as the limit of f of x as x goes to some number c. So as x is getting closer and closer to c, what is the value, what is the y value of the function getting closer and closer to? Well, I want to talk to us today for a little while about different types of limits because you can't always just plug and chug, like I like to say. So, for example, number one, there's a couple of things here. It says find the limit when you've got, there we go, when you've got x minus 5 when x approaches negative 1. So find the limit as x goes to negative 1. Well, for this, if you just take f of negative 1, you get negative 1 minus 5, and that's going to give you negative 6. So in this case, the limit as x approaches negative 1 of f of x is negative 6. Or you can say that the limit as x approaches negative 1 of, and actually write the function, x minus 5, is negative 6. On the AP test, if you do not write the limit as x approaches negative 1 of f of x equals negative 6, if you do not actually write this as your answer with the limit included, you will not get any credit for it. You cannot just simply circle 6, negative 6, excuse me. You must write the limit as blah, 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 blah. You have to include the limit. They are looking for the limit. We'll go into a little bit more about the AP test later, but I want to get that out of the way now. Okay, so here again, find the limit of this function as x approaches 3. So you take f of 3. It's going to be 3 over 3 minus 1, right? Always in parentheses here. That's going to give you 3 over 2. So in this case, the limit as x approaches 3 of f of x is 3 over 2. That's how I'm going to actually write my answer. I'm going to write it as a limit as x goes to such and such. I hope y'all can see that. Yeah. Okay, so from here, I want you to notice and take a note that here plugging is really no problem. Just straight plugging in is really not an issue. And there's a couple of reasons for that. If you think about this line or this function right here, x minus 5, let's call this negative 5, right? And you've got a slope of 1, so looks something like this. That function is always going to exist. At every x, this thing is going to be defined. So that's not too terrible. You're finding it as x approaches negative 1, so you're trying to find this point right here. You're actually trying to find this value. And it actually exists. For number 2, this function kind of looks something like this. It does have a horizontal asymptote at 1, right? And horizontal asymptote is the coefficient over the coefficient, leading coefficient over leading coefficient. 1 divided by 1 is 1. It has a vertical asymptote. If we set this equal to 0 and solve, it has a vertical asymptote of 1. Right? So it's going to look something kind of like this. And you're trying to find the limit as x goes to 3. Well, here's 3 on the x-axis. The limit is actually there. I mean, it actually exists there. That's why plugging in is not a problem here. Just plug and chug. So for these two, plugging in, go ahead and write this on there, is no problem. Yeah, da-da-da. Clouds for this one or for this one. Plugging in's no issue. So what happens then if plugging in becomes an issue? What happens if you can't just plug straight in? And I know what I'm talking about here, so I'm going to go ahead and give this to you now. Like on this one, it says the limit as x approaches 2. Well, if you plug a 2 in here, 2 minus 2 is 0. 2 squared minus 4 is 4 minus 4. That's 0. Plug a 2 in there, you're going to get 0 over 0. Right? That doesn't exist. That's an issue. We got to get around that. You plug in a 2 over 2, that doesn't exist. I mean, if you plug in a 2 to both of those places, it's an issue. Same thing for negative 2. Let's take this to a different spot. If you put a negative 2 in here, again, you're dividing by 0. Big issue. So here's what we're going to do for that. I'm going to write this down. Plugging in is a problem. So factor. If plugging in is a problem, you are going to factor. There's actually two things you can do. We'll discuss both of those here in a moment. But the first thing you have to do is factor. All right? So for starters off here, I'm going to factor. The top is actually done factoring. So we'll say that f of x is x minus 2. Sorry about the AC. X squared minus 4 is the difference of two squares. X plus 2 and x minus 2. I'm actually going to be doing a video later, probably this weekend, on how to factor. So keep posted for that if you're having some issues factoring. Now look at what happens here. You've got x minus 2 and x minus 2 can cancel. So f of x is really just 1 over x plus 2. Let me kind of keep this separated. F of x is really just 1 over x plus 2. So if that's the case, plug that in. Plug that into your function there. Plug your 2 into f of x. Now it's 1 over 2 plus 2. So now the limit as x approaches 2 of f of x is 1 over 4. The limit as x approaches negative 2 of f of x, if you put a negative 2 in here, you get negative 2 plus 2, which is 0. So this one does not exist. That limit does not exist. Now let's talk about why. This has a horizontal asymptote here. Your power on the top is smaller than your power on bottom. So it has a horizontal asymptote at 0. And it has a vertical asymptote, if you set this equal to 0, at negative 2. That's why when you plug in a negative 2 here, this thing goes crazy, because it actually doesn't touch that. Here's what your function actually looks like. So over here at 2, you've got about a fourth. Really? You gotta be kidding me. How's that for a break in concentration? Good night. Okay. I start practicing for Friday. Okay, that's example 3. This is going to be forever. Example 3. Or 4. We just did 3. 4. Same thing here. Factoring is an issue. Or plugging in, just take my word for it. If you plug in here for 1, 1 minus 4 plus 3 is 0. 9 minus 12 plus 3 is 0. So both of these limits are going to give you some issues. So we're going to factor x minus 1 up top. On the bottom, it's going to give you x and x minus 1 minus 3. Right? Your minus 1s can go away. So you are left with 1 over x minus 3. So you'll say that the limit as x approaches 1, f of x is, you plug a 1 into here, 1 minus 3 is negative 2. 1 over negative 2. And the limit of f of x, I don't know why I do some else cursive and some print, I have no idea. X approaches 3. 3 minus 3 is 0. That does not exist. So there's a couple of things that you can do to remember this, and they're written down here. You can always use a table or a graph to reinforce your conclusion. That's kind of what I was doing up here. You can always graph this thing and actually come up with whether or not you're actually getting the right answer. That's okay. You can do that. If plugging in gives you an indeterminate means something over 0. I don't care what the something is. It could be 0 over 0. It's still dividing by 0, and it's still indeterminate. You're either going to factor or multiply by a conjugate, then plug it in again. Always start by plugging in, right? This is like number 1. You always do this. All right, you could say you always do this first, even. First, you always plug in. Then you factor, or you multiply by a conjugate. Now, some people might not realize what multiplying by a conjugate is. These are for your square roots. All right? Conjugate changes a plus sign to a minus sign, and it's still your square root. Then you plug in again. We're going to get into more of that on the back. So let's go to the back. All right, we got a couple of questions on the back here. Number 5, we've got 3 minus the square root of x is equal to 9 minus x. 2 ways that you can do this. You can factor. Now the factor method I don't really recommend here because of what you have to do. You have to treat the bottom as the difference of 2 squares. So this is 3 minus the square root of x, and the bottom, you have to treat this as a squared and this is b squared. So you're going to end up with some more square roots. Remember, it's a plus b, a minus b. Square root of, good grief. The square root of 9, which is 3, plus the square root of x. Square root of 9, which is 3, minus the square root of x. I don't really recommend this way because it gets confusing, but it is effective. 1 over 3 plus the square root of x. So you're looking at the limit here. I should have wrote that down first. So the limit as x goes to 9 of 1 over 3 plus the square root of x is equal to 1/6. And that's not horrible. It's not bad. If you plug a 9 in here, square root of 9 is 3. 3 plus 3 is 6, so on and so on. So that's not horrible. The conjugate method, I believe, it's a little bit more work. To some people it may make sense. Let's go ahead and do that. The conjugate method. The limit as x goes to 9 of 3 minus the square root of x over 9 minus x. Now the conjugate, you pick your square root, right? Pick the square root you're trying to get rid of. The conjugate of that means changing this to a plus sign. If it was a plus sign, I'd change it to a negative sign. All right? So I'm going to multiply the top and the bottom by 3 plus the square root of x over 3 plus the square root of x. Now what that does for me on top, 3 times 3 is 9, plus 3 square root of x minus 3 square root of x, so those go away.